These are notes for 4A, which is the first section in Unit 4, over solving a system of equations by graphing. So the first thing we're going to do is define what is a system of equations. A system of equations is when you have two or more equations on the same graph. So we're going to graph two lines on the same graph, and their solution is the point where they intersect. So I'll do our first example down here. So I'm going to start with this one here, and we're just going to graph both of them on the graph below. So if you remember, I'm going to start at my B, which is -4. So I'm going to go down 4. That's where my first point will be. And then I have to follow my slope of -2, which remember is really like -2/1. So I'm going to go down 2 to the right 1. Or from that point, you could also go up 2 and then to the left 1. It's as long as you're going in a negative direction. So remember, this is a positive line. This is a negative line. So just make sure that you're going in the negative direction because we do have a negative slope. And you want to go a bit further than we usually do because you don't know yet where they're going to intersect. So if you don't go far enough, then when you draw the other line, if there's not a clear intersection, then it's going to be hard to tell. You might get the answer wrong. So I would go farther. I would go almost the whole graph. And if that still isn't enough, you can always go back and add more points. So that's my first one. And then my second one, I'm going to graph that one. So this time I'm going to start at +6. And I have a slope of 1/2. So from here, I'm going to go up 1 to the right 2, or down 1 and then to the left 2. And I can see it's probably going to be intersecting somewhere over here to the left. So instead of continuing to go up to the right, since I know it's not going to intersect there, I'm just going to go down 1 over 2 and keep going in this direction. And then I can see where they've intersected now. So as you can see, if I didn't make my blue one long enough before, maybe I stopped here and like I put my arrow here, then I wouldn't know where they intersect. So I'm going to circle this point here, and that's my solution. So my solution is -4, 4, because this point is to the left 4 and then up 4. So -4, 4. So when it asks for your answer, this is the answer technically. But you do have to show all of your work, so you're going to have to show all your graphing. Okay, let's try it again. So I have this one right here. So I'm going to start all the way up at 10. And then I have a slope of 2, and there's really only one way I can go from here. So I'm going to go down 2, and then to the left 1. And I'll connect those points. Then my next line will start at +1. And I'm going to go up 1 to the left 4. And I've already hit my point of intersection there. But I'm going to go ahead and just go over one more, just so I have a clear indication where my line is going. And then this time my solution is here where they're intersecting. And this time it's at -4, 2. So again, this is my answer. We have to show all of the steps to get there. Okay, next we're going to practice when we have some that are not in y = mx + b form. So you always want to check, is it in y equals mx plus b? So is it in slope-intercept form? If it's not, we have to get it in that form. So we want to get it to so where it says y equals something. So we have to get that y alone. So to do that, I'm going to take this first equation here, and I'm going to focus on getting this y alone. So I'm going to go ahead and rewrite this equation down here so I have some space to work. So I want this alone. So to get that y alone, I need to get rid of that 15x. So I'm going to subtract it from both sides because we always do the opposite. So those cancel. I have 5y equals 25 minus 15x. Again, trying to get that y alone, so I'm going to divide by 5. And then I have these cancel, so I have y equals 25 over 5 just becomes 5, and negative 15 over 5 will become negative 3. Now it's almost in y equals mx plus b form, except this is my slope, and my slope should technically come first. So what I'm going to do is I'm going to rewrite that. Let me put it over here. So I'm running out of room. Y equals negative 3x plus 5 because I want my slope to come first. So this is the new equation that I'm working with. So now this is my first equation, and my second equation is still this one. But if you notice in that one, my slope is still coming second. So I'm going to go ahead and rewrite that just for clarity. Y equals negative 3x plus 5. Now you might have noticed these are the exact same equation. If you have the exact same equation, when you graph them, it's going to be the exact same line. So our answer is going to technically be infinite, but I still need to show that. So I'm going to start with graphing my first one. I'll start at positive 5, and then I'm going to go up 3 to the left one, down 3 to the right one. I'll graph that. Now my second line will also start there. I'm going to have the same next two. So I'm showing still that I'm making a line on top of the line. So my solution is infinite, or you can write the word infinite. And it will always be infinite if you have the exact same line. Okay, on our next one, neither of these are in y equals mx plus b form. This one is almost in that form, except the slope somehow needs to get over here. So to do that, I'm just going to add the 2x to both sides. So if I rewrite this, I'm going to add 2x to both sides. So I get y equals 2x plus 6. So that will be my first line. And then my next one is also not in that form. I'm going to have to do the same thing I did on the last problem. So I'm going to start by adding the 4x to both sides. Those go away. I have 2y equals. And also make sure you don't accidentally combine these. 8 and 4x are not like terms. We can't add them together. So I just have to write them out. And if you want to go ahead and put your slope first, you can. So that would just be 4x plus 8. Or you could write 8 plus 4x and then rearrange it at the end. But just make sure you're not combining them. Then I'll divide by 2. Y equals 2x plus 4. So this is my first line. This is my second line. So I'm going to start with my first one. I'll start up at 6, up 2 over 1, then I'll make my second line, This time it starts at 4, up 2 over 1 again. Now, if you notice here, they have the same slope. And if you know something about lines that have the same slope, it means that they are parallel, and that means that they're never going to touch. So no matter how far I draw this line, either one, they will never touch. So that means that we have a no solution. And that will happen every single time you have parallel lines. So if you ever see the same slope but different intercepts, it's going to be a no solution. Now we have one more thing here I want to go over. If you remember our Hooy Vux that we talked about. So the HOY, that stands for horizontal, zero slope, and then it crosses the y-axis. And then the Vux, we have vertical, undefined slope, and then x-axis. So the one with the y is going to go with this one. This is going to be my horizontal line. And then the one with the x is going to be this one. That is going to be my vertical line. So if you see something like this, the lines are just going to be, you're going to have one horizontal and one vertical line. So let's start with my x equals 5. So I'm going to go to the x-axis and I'm going to go to 5, and it's just going to be straight up and down. And then for my y equals 3, I go to my y-axis and I go to 3, and I go straight across. And if you notice, their point of intersection should just be what these numbers are. So my answer is 5, 3. So if you have lines like that, where one's horizontal, one's vertical, it should work out like that.